My name is Vahan Davudyan. I'm a physics experimentalist for 30 years. Sorry, I have to sit because I have some experiment. So I have some water, so I have to be here so I can show you how everything works. And first of all, I'd like to thank YouTube for this wonderful opportunity for us so we can upload our videos. Some other people can upload their videos. We exchange views, we learn a lot. And in fact, I call the YouTube synapse. They are like in our brains, junctions and connecting billions of neurons. And in other words, like YouTube is like a huge network or university so we can learn. And in fact, I call this YouTube is the key to learn. And today, this is the topic. During the tide by moon, ocean's water is lagging behind. I have seen this in so many videos, but the mystery was why the ocean's water, after the bulging by moon's tide, why is lagging behind. And finally, after so many years, I found the problem because the water cannot be accelerated like solids. And this is my email, vahamdavudyan1948@gmail.com. The amplitude of the oceanic tides caused by moon is about 54 centimeters approximately, or 21 inches. The moon and earth exert a gravitational pull on each other. On earth, the moon's gravitational pull causes the oceans to bulge out of both sides closest to the moon and the sides farthest from the moon. These bulges create high tides. I have to demonstrate this so you can see it. I made this so you can see this is the way. See, moon, in fact, the moon is like a tidally locked with Earth, and it takes like 27 days to go around the Earth. Well, it's not like, we have like a Earth and Sun. Moon is different, it's locked. So you can see this bulges, so moon is traveling with the earth. You can see this, so this is high tide and this is low tide. But you can see the moon, but it's always the moon is traveling, and in fact this is aligned, but most of the time what happened, the water is lagging behind the ocean's water. The reason why, like I said, water is different. It's not like solid. It can assume any shape because of the molecules. And I have here something you can comprehend much better. See, this is the sun, and this is the moon, and this is the earth. You can see when they are aligned in the same line, so you can see now the earth, moon, and the sun are in exactly the same line, and the gravitational pull is getting much better. It's called the spring tide. Well, whenever the moon is like 90 degree or in angle, it's called neap tide. It's always a little bit less because it's not exactly the way the moon and the earth and sun they add together. This is another poster. This is the continuation of the first one. I show you. So the low points are where the low tide occur, and the moon's gravitational pull on Earth combined with the other tangential forces cause Earth water to be redistributed, ultimately creating bulges on the side closest to the moon and the side farthest from the moon. Twice a month, when Earth, Sun, and Moon line up, their gravitational power combined to make a spring tide, which I showed you a few minutes ago. Earth's tidal bulges do not line up. This was my problem. I was wondering why. Well, of course, the scientists explained they do not line up, but I had no idea why. I had to find a problem. they do not line up exactly with the moon position because moon is orbiting in the same direction. Well, of course, in this one, I explained why. Okay, as the Earth rotates, it takes extra time for any point on our planet to rotate and reach exactly below the moon. The high tide bulges are never directly line up with the moon, but a little behind. So this was the problem. I had to find this problem. Calculating tsunami and Earth tsunami can never travel in tsunami can travel in Pacific Ocean about 24 hours, and it is like 15,500 divided by 24 hours is 645 kilometers tsunami can travel. But you know, when I compare this with the Earth in equator, is approximately 1,670 kilometers divided by 12, it comes to 1,291 kilometers. So if I deduct this, I can see that tsunami is traveling 645 kilometers more compared to normal, the way the Earth is rotating. But why? I have to show you on this globe. See, this is the small globe you can see. I had to get this Pacific Ocean exactly, well, of course, it's not 100%, but it shows. On equator, you can see there is no land at all. There are few small islands, we can ignore those. So you can see it's exactly 15,500 divided by 644, but the Earth is practically less. So imagine that is a difference. The reason why that huge energy is released in the ocean. It doesn't matter. Here, there, and then the water is so different. It's not like solid. It's traveling with the Earth. I can show you in a few minutes exactly what I mean. So that's the reason why that huge amount of energy is released in ocean, and it's called tsunami. And as you guys remember, many years ago, it killed almost more than 100,000 people, because when the water goes in, it's not a problem. When it's receding, it's washed out everything, which is so devastating. This is another poster. Well, of course, I don't show moon over here, but you can tell these arrows represent the tidal forces. And in fact, let me read this for you. Moon gravity is pulling the oceans toward it. How can ocean also bulges on the other side? Because of the tidal forces is a differential forces. So it's a stretching and the squashing. So if it's a stretching on this side, it's a squashing on the other side. And immediately I remember this is fantastic phenomenon. It's called red shift, blue shift. You can see she's over here and it's stretching the wave, and he is over here and is stretching. No, here's it's just a squashing here. On the other side, you can see he's here, it's stretching. So what it is, this stretching and squashing is proportional, and it doesn't matter how it does it. So that's why we can see bulges on both sides of the Earth, and this is why. And in fact, I have another idea. I had to print a tsunami because this is one of those nature's amazing things happen. And in fact, I had to, let me put this up, you can see. I had to compare this with the electromagnetic waves. Let me show you what I mean by that. So in electromagnetic waves, I discussed this by year 2000. You can see vertical, horizontal, and then this is the way the electromagnetic waves travel. And see on the bottom, I have this anomaly. You can see that is crest, trough, crest, trough, crest, trough, and it goes all the way. By the time it gets to the shore, it cannot travel anymore. So imagine if this was Pacific Ocean, it would travel all the way to Hawaii. But in Hawaii, what it is, it's a land. So it has to slow down, and that's what it is. And you can see always, the trough is there, the trough is here, and then crest is here. Trough is here, crest is. See? Trough, crest. Trough, crest. It's exactly like electromagnetic waves. This is another poster I can show you. See? They are acting exactly because Moon's gravity is much less, is 6 times less, and the Earth's gravity is 6 times more, so it's proportional. As the Sir Isaac Newton said, it's m1, m2 divided by r2 square law. This is exactly what happened for the water as well. So you can see low tide and a high tide. I have seen this phenomenon in Austria like 30 years ago, and I remember this is fantastic phenomenon. I show you what I mean by this. This was in 1992 in Austria, in Vienna, and then this was like almost, I would say, approximately 30 or 40 meters long pool, and they had mechanical device. It would create bulges. It would create a wave, and people loved it. Then I remember one time we had fruit, and then I had to put one apple on the surface of the here, and then as soon as the wave started, and then I saw something amazing. The apple rises and falls exactly with the crest, where the crests are. Then it is not advancing at all. It's going up and down, up and down, up and down. Well, unfortunately, I don't have it in my lab because I need at least like 10 or 20 meters long, a rectangle plastic container. But I demonstrated here, if I have, any liquid here, especially, if I have like red color, blue color, it shows much better. So these are the, half filled. Then if I leave this, and then if I create waves here, you can see this bottle is not traveling. But, so in other words, it's always where the crest are is right there, see? But it's not traveling, it's going up and down, up and down, up and down. So water travels with the, so that is the way it works. And in fact, I have some experiment I show you, but before I go to my experiment, I have to explain something else for you guys, because you will love this idea. I was always fascinated by aerodynamic and hydrodynamic. Even from high school, I remember this was my favorite subject, and in fact, I had so many theories. Like a year ago, if you go on YouTube, you can find those, for the birds and things like that. So imagine these old airplanes, because I'm not talking about the new. See those propeller? This is acting with air, and this is like a boat, and this is also propeller. But you can see it's almost the same. This is a little bit wider, but it doesn't matter. So when I compare this, and then I realized that water cannot be accelerated. I mean, how could I prove this? And then finally I remembered the Dead Sea, and that is one of the amazing phenomena in our, you know, we have like Dead Sea in Middle East, and we have Lake Urmia in Iran, north of Iran, and the salinity is almost like 28% to 34%. It's amazing. And in these lakes, you never get drowned. The reason why buoyancy is so good. And then I was wondering, if I have like propeller like this, can I have more thrust, linear motion compared to the fresh water? And then I checked, I was right. When you have like, you know, salt water like those, you know, Dead Sea or Urmia, you can have better thrust, and then you can do. An airplane is the same way. Imagine if I'm flying over the mountain in Denver, Colorado, this aerodynamic force is not going to be as good as if I'm in Santa Monica in California because of the level. So the air density is not as good over the mountains. So that's exactly what happened. And if you think about that, air is also like a liquid. But in liquid, it's so amazing. Always in a water with more salinity, like, you know, Urmia or Dead Sea, because of concentration of so many dissolved, you know, sodium and some other things, they can propel more. And imagine, of course, this is a hypothetical, idea, or this is a weird idea. What if our oceans were, because oceans overall, all over the world, it depends on, I'm talking about overall, the salinity is only 3.0 to 3.5, which is cannot even be compared with Dead Sea to 27 to 34%. They're pure, like, you know, salts and some other things. So imagine, I was thinking, if our oceans were like at least 26% salinity, we won't have this problem. So the water would always be accelerated exactly with the thing. And this is another thing you can see. It shows perfectly. If you compare the electromagnetic wave, it's almost the same. It's amazing how nature, everything is the same. Look at here. If you compare with electric field, magnetic field, electric field, magnetic field, this is the crest drop. And imagine, this is also called the wavelength. The same thing works in electromagnetic waves. It doesn't matter, and that is the amplitude. And if you have, like I said, you know, like a container here, half filled, it's going to go up and down. It's not going to travel. So what it is, we have to accelerate the earth, water, by force. And the only thing I could think, this is amazing for the transporting liquids, and this came in my mind. I said, this is a good idea, so I can show you how we can accelerate the water. See, this 18-wheelers, sometimes they take like 40, 50, 60, 100,000 liters, liquid, water, everything, gas, or you name it. But imagine if there was no baffles here. See, this is a baffle, exactly like a car seat belt, is slowing down. What if the driver is driving so fast, he slams on the brake, the water is going to go rush here, slash over here, and the poor driver is going to get killed. But see, these are slowing down exactly like a seat belt. What if this was open? We cannot accelerate the water. The only way we can accelerate, if I remove all these baffles, and then I slowly accelerate and decelerate, and there's someone from here, you can watch from that window, you can see the water is traveling like a wave. It's going from here, there. So in other words, because it can assume any shapes, you cannot accelerate the water. So I was not satisfied with this, so I had to come up with so many ideas, but how could I prove this in a science lab? You see, this is amazing device. I have rotating disc here. Let me show you. I have a rotating disc here, and then this is a bowl of water, and see this is rotating, it can, and then I have an index here, see red, and then when I float this, see, these are two pieces of wood like that, I had to mark them red so you can see. When I float them, this was my best day of my life, because this is the way I could prove that the water is not accelerating exactly like solids. It's always lagging behind. So imagine if I rotate this, you can see this is the index, see. That's 1, that's 2, that's 3, that's 4, 5, 6, 7, 8, 9, 10. Did you see what happened? After 10 rotations, see, because they are buoyant and then they are floating in the water. After 10 rotations, these are finally getting rotated. So what happened? Earth is going with the water, but the moon's gravity is pulling, at the same time is causing the bulge. So because water can be shaped it doesn't matter, it's soft. I mean, the molecules are so different. I was not happy with this. I said I better do some other things. I show you one more thing. See, this is like a star, you can see. I mean, cross, and then I color them. You see, this is filled with water. And then if you can look here, this is your frame of reference. You can see red, so this is the disk and this is the ball. But imagine if I line this up, this arrow with this red, you can see I have to rotate this many times, and finally this cross is going to rotate. See, that's 1, 2, 3, 4, 5, 6, 7. See, after 7 or 8 rotations, finally it starts rotating. So the reason why this momentum is not conveyed to the water. This is another one. Of course, this is a little bit heavier. So I put it, see, it's like a cross, and then I had to put a little bit weight on it. So you can see, if I align with this, it's the same thing happen. Well, it doesn't matter if you do clockwise or counterclockwise. See, now as 1, as 2, 3, 4, 5, 6. See, after six rotations, finally it's rotating. I was not satisfied with this. I said, what if I make my own propeller and then put it in the water and then I rotate it, see what happened. I show you. This is the propeller. I made it from aluminum, so you can see. Well, of course, it's not as good as the one the ships are using. So I had to put some of these little foams, you can see, floating in the water. Let me show you. Well, of course, it must be staged. It must be. I have to stop the water because it's still rotating. You can see, because I was rotating a little bit while I was still going slow. But finally it's going to stop. So when I put this propeller, and then it doesn't matter if I go clockwise or counterclockwise, it doesn't matter. It shows that, even though I'm accelerating the water, even though I'm just pushing on the water, it's not going to go anywhere. Let me show you. So I submerge this in the water and they start rotating. See? See what happened? The disc is still here. See? My disc is still here. This is my frame of reference. And then this is the ball. See? You can see? is not rotating at all. And then I can put a little bit more of this foams. You can see. Of course, I have to stop the water and then. See, while I'm rotating that propeller, they are not rotating because that momentum is not transferred. Well, of course, I have another one. This is a little bit different. I show you. Let me put this down so you can see. This is another one. It's too much water. This is a little bit different. So what it is, I have to put ball bearing so you can see, you can accelerate it, but decelerate this. But the reason why I did this, I just wanted to show you that, even if I have the propeller here, see, I cannot accelerate the water. See what happened? I'm rotating, but I can't do anything. Even if I wave it like this, you can see something amazing. The one I told you like a few minutes ago, water is traveled with the wave. See, if I have a piece of wood here floating on the water, if I slide it back and forth, see what happens? The wave is here. And where this wood is traveling is on the, crest. It's not on the trough. So it's going like that. It's going like that, up and down, up and down. Let me show you one. So in other words, I came to this conclusion that's the only way we can accelerate the water. We can put it in a pump, of course, and then, force it. But overall, you cannot accelerate the water because water can assume any shapes. So at least, I'd like to thank so many viewers, My last one, a month and a half ago, it was for the Earth's rotation because I was in France a few months ago, and then I saw Focus Pendulum, and that was great success. So many people loved it. They, subscribed, and then they gave me thumbs up, and then they loved that idea. That was a little bit long. That was 1 hour and 17 minutes, but that was great because I did that by year 2000, but this time was so comprehensive, was 100%, and then I'm glad I did that. And this is another one. So I'm hoping in another month I will publish more because I have like 30 more theories, and then I'm trying each month. I was so busy. And at the same time, I'd like to thank so many people. They just emailed me, even some university professors. They thanked for everything, and the precision was 100%. And that is great encouragement for me. And the feedback is so important in science. If there's no feedback, I have no idea how I did it, and I appreciate that. And then I'm hoping you would love this video. Well, of course, like I said, maybe I did not cover everything, but I'm glad, at least this was a phenomenon, because this is one of those phenomena happened in a solar system a lot, but we have to know why the water is lagging behind. It is not going exactly with Earth. So this is what happened. Well, of course, I have to mention something. After like 6 hours, 6 hours, and then water is catching finally. But overall, because the water is soft, well, soft, I mean the molecules are so different. You can put in any container, it assumes the same thing. But my main idea was that you cannot accelerate the water. And thank you for watching, and I'm hoping you like this video, and if you like it, you can subscribe it, and if you have any questions, like I said, you can email me. I really appreciate your feedback. Thanks a lot for watching. Thank you.